Virtualization is a combination of software, hardware, and networking technologies that enable a single physical computer to act as though it were multiple independent computers. A virtual machine, or VM, is a software emulation of hardware resources that behaves like a physical computer. Virtualization uses host software, called a virtualization layer or hypervisor, to control the physical hardware resources and configure these resources to support one or more VMs. Hypervisors come in two basic types: bare metal hypervisors and virtualization environments. Virtual machine is a completely separate individual operating system or network operating system installation on your usual operating system. It is implemented by software emulation and hardware virtualization. Virtual machine is a software implementation of a physical machine, computer, that works and executes analogically to it. Virtual machines can be an operating system or a server. A virtualization layer manages physical resources and allocates them to one or more VMs. To prevent VMs from interfering with one another or with themselves, the virtualization layer intercepts and interrupts from VMs that require access to physical resources, makes these resources available, and then passes control back to the VM's interrupt handlers. Duplication of interrupt handling degrades performance, which can be minimized by allocating some physical resources exclusively to one VM. Some virtualization layers use customized device drivers installed in VMs to improve performance. Hardware in general, and CPUs in particular, have evolved to include features that improve virtualization performance. These features include extra registers, CPU operating modes for the virtualization layer, and optimizations to support chipsets and I/O devices to streamline the interface between virtual and physical I/O devices. Intel CPUs enable a hypervisor to trap CPU ID instructions issued by VMs and alter the features reported to these VMs. The capability enables computing clusters with multiple CPU types to report consistent CPU features, which makes it possible to move running VMs to other cluster nodes. VMs go hand in hand with virtual networks, which are emulations of physical networks implemented in a virtualization layer or host. Virtual networks interconnect VMs, emulated network devices such as routers and firewalls, and the virtualization host's physical NIC. Fully functional virtual networks might also require virtualized network services, such as DHCP and DNS servers. Fencing virtualized networks enables cloned VMs with identical MAC and IP addresses to operate concurrently on the same virtualization host. Virtual machines are divided into two categories based on their use and correspondence to real machine: system virtual machines and process virtual machines. First category provides a complete system platform that executes complete operating system. The second one will run a single program. Frequently, multiple virtual machines with their own OSs are used in server consolidation, where different services are run in separate virtual environments, but on the same physical machine. Multiple OS environments can exist simultaneously on the same machine, isolated from each other. Virtual machine can offer an instruction set architecture that differs from real computers, such as Mac versus Windows. It has easy maintenance, application provisioning, availability, and convenient recovery. Centralizing a network management, it reduces dependency on additional hardware and software, etc. Virtualization and cloud computing is easier for enterprises of all size to benefit from the high performance and availability of networks without the cost of running your own hardware. Virtual machines are ideal for small to medium enterprises that need a reliable service at low costs. When multiple virtual machines are simultaneously running on a host computer, each virtual machine may introduce an unstable performance, which depends on the workload on the system by other running virtual machines. Virtual machine is not that efficient as a real one when accessing the hardware. Virtualization programs such as VMware, ESX, Microsoft Hyper-V do not feature USB and serial ports in virtual machines. So in other words, you cannot access USB or serial devices physically plugged into a host machine on a virtual server. This uses less hardware to run the same type and amount of software, which brings down all the costs overall. Lower energy consumption, since you're running less computer hardware to accomplish the same type of work, And the familiar interfaces are the virtual environments are built to mimic physical ones, so you should never have any idea that you're running on a virtual machine. Virtual networks include virtual NICs, virtual switches, and so on. Other than being able to physically move a server, you'll receive similar experience and performance on a virtual network that you would with physical servers. High availability. By distributing a load across virtual machines, virtual hosts are able to ensure high availability of applications and data. Even if one server fails, another virtual machine can be spun up with minimal downtime or data loss. Scalability. Virtualized machines allow scalability on demand without adding physical resources, and they can be expanded much easier than in a physical machine. Adding additional RAM to a virtual machine can be done in a few minutes, while it can be up to a day's work for a physical machine. Backup with fast recovery. Virtualization and cloud computing offer powerful solutions for data backup and recovery. Even if hardware should fail, virtual machines can instantaneously and accurately migrate data to working hardware with little or no downtime. Simple data recovery is another great advantage of this technology. For instance, if your virtual server suddenly becomes corrupted, you simply delete it and restore it from its virtual backup. You do not need to spend time and effort on restoring your entire system from scratch and then restoring it from the latest backup. So a corrupted virtual system can be recovered in mere minutes. Easy cloning. Cloning a virtual machine just takes a few clicks and a matter of seconds, where cloning a physical machine can be a serious undertaking. Virtualization provides you with a safe platform on which you can test various software configurations and on various platforms prior to deployment. So in effect, you can tinker with the software until you get exactly what you want without inadvertently damaging your existing network. Better system security and reliability. Virtualization systems do not crash due to corruption, like device drivers or memory issues. Security. If you're moving applications from physical servers to a public cloud, there are a number of security risks since your cloud servers will be hosted on virtual machines in a shared infrastructure. Virtual hypervisors are easier to harden against attack than an operating system, but they are still complex systems that offer a new target for attack, especially in a public cloud. DataPipe offers an ultra-secure cloud environment that is closely monitored to ensure security. Potential downtime. While it's unlikely that your virtual resources will all fail at once, it can be more difficult to reboot virtual machines in the event of a catastrophic hardware failure. Virtual machines can power on and off just as easily as a physical machine, but a VM coming online from a host crash will need to wait for their physical infrastructure to boot, plus the time it takes for your virtual machines to boot as well. The additional downtime may not be outrageous, but it can add up. Oversubscription. Almost all modern cloud environments are built on an oversubscription model, so it is possible to oversubscribe your virtual machines on physical hardware. Essentially, if you have 5 VMs using 2 GB of RAM running on a physical machine with 8 GB of RAM, you've oversubscribed that hardware. Luckily, oversubscription does not mean overcapacity. Avoiding oversubscription on your virtual machines requires attention to resource allocation to ensure you're properly utilizing your virtual resources when they're needed. VirtualBox, Windows, Linux, and for Mac OS X, VirtualBox is very popular because it's open source and completely free. There's no paid version of VirtualBox, so you don't have to deal with the usual upgrade to get more features, upsells, and nags. VirtualBox works very well, particularly on Windows and Linux where there's less competition. It's a good place to start out. VMware Player for Windows and Linux has their own line of virtual machine programs. You can use VMware Player on Windows or Linux as a free, basic virtual machine tool. More advanced features, many of which are found in VirtualBox for free, require upgrading to the paid VMware Workstation program. We recommend starting out with VirtualBox, but if it doesn't work properly, you may want to try VMware Player. VMware Fusion for Mac OS X Mac users will need to buy VMware Fusion to use a VMware product, as the free VMware Player isn't available on a Mac. However, VMware Fusion is more polished. The Parallels Desktop for Mac OS X also is available for Mac users. Both Parallels Desktop and VMware Fusion for Mac are more polished than the virtual machine programs on other platforms. They're marketed to the average Mac user who might want to run Windows software. Linux includes KVM, an integrated virtualization solution. Professional and Enterprise version of Windows 8 and 8.1, but not Windows 7, and it includes Microsoft's Hyper-V, another integrated virtual machine solution. The benefits of virtualization outweigh its cost in many deployment settings. One benefit is that consolidating multiple VMs on a single computer or cluster usually reduces overall hardware requirements. Consolidation also reduces supporting resource requirements such as space, power, and cooling. System administration and support costs are usually reduced by limiting the number of VM configurations and using clones, templates, and snapshots to manage these configurations more efficiently. Combining these benefits yields to a higher degree of deployment flexibility and scalability than can be achieved without virtualization. Additional costs and risks of virtualization include the cost of the virtualization layer, the need to use higher performance hardware and software in virtualized settings, and the risks associated with fewer physical points of system failure.